We're about to go on an absolutely epic journey, one that's going to stretch your imagination to its absolute limits. Together, we're going to scale up from individual stars and galaxies all the way to the largest known structures in the entire universe. So, yeah, let's get started.
It's such a simple question, right? But the answer? Oh, it's anything but simple. To even begin to wrap our heads around it, we have to completely recalibrate our sense of scale. I mean, the structures we're about to see are so unbelievably vast, they pretty much defy description.
So, to get our bearings, let's use an analogy. I want you to imagine our entire Milky Way galaxy. With its hundreds of billions of stars, imagine it's just this one single grain of sand. Okay? Hold that image in your mind. This is our reference point as we step into the cosmic ocean. Our journey starts with the fundamental building blocks of the cosmos, galaxies, these vast, glittering cities of stars. But, before we even start comparing galaxies to each other, let's get a feel for the scale right here in our own cosmic neighborhood. Our sun, it feels enormous to us, right? But really, it's just an average yellow dwarf star. Now compare that to a hypergiant, a real monster, like Uice-Cutie. It is over 1,700 times wider than our sun. I mean, if you placed it where our sun is right now, its surface would stretch out way past the orbit of Jupiter. Just think about that for a second. And that's just a star. Okay, now let's make the real jump to the galactic scale. Our Milky Way is a staggering 100,000 light-years across. But even our massive home is completely dwarfed by behemoths like the galaxy IC 1101. At nearly 6 million light-years wide, you could fit more than 50 galaxies just like ours inside it. And it contains an estimated 100 trillion stars. But here's the thing. Galaxies don't just float around randomly. Nope. There's a fundamental force at work, this invisible architect sculpting the cosmos into structures of truly staggering proportions. And this is all part of a grand design. You see, gravity's relentless pull is the cosmic architect. It gathers individual galaxies into little groups. Then, over eons, those groups merge into massive clusters. And, well, even those clusters are drawn together into the next level of the cosmic hierarchy.
And this is that next level, the supercluster. Now, these aren't just collections of galaxies. They're collections of galaxy clusters. These are the largest gravitationally bound objects we know of, the true titans of the cosmos.
And guess what? This is where we live. Our own cosmic address is the Laniakea supercluster. Our Milky Way is just one of roughly 100,000 other galaxies inside this colossal structure, a structure that spans over 500 million light-years. It's mind-boggling. But believe it or not, even a structure as vast as a supercluster isn't the final level. So now we're going to zoom out again to the absolute largest scale of organization in the entire universe. We're moving beyond things that are just held together by gravity and into this grand foam-like pattern that defines the entire cosmos. The best way to visualize it isn't as something solid, but as this delicate, immense network. Imagine a cosmic honeycomb, or maybe a spider's web, stretching across, everything. Superclusters are like the bright, dense spots where all the strands of the web intersect. This web is made of a few distinct parts. You've got the long, glowing threads of galaxies called filaments. Then there are these unimaginably vast sheets of matter called walls. The dense, bright intersections where all the action is, where superclusters live, those are the nodes. And separating it all, the voids. These vast oceans of near total emptiness. Really, the contrast between where matter is and where it isn't is what defines this whole structure. So let's take a look at one of the most jam-packed regions ever found, and one of the most desolate. On one hand, you have structures like the Boss Great Wall, which is a chain of superclusters stretching for 1 billion light-years. And on the other hand, you have the Boat's Void, a region so empty it's actually nicknamed the Great Nothing. In a volume of space that's nearly 330 million light-years across, astronomers have so far found just 60 galaxies. 60. That's it. To put that into perspective for you, based on the average density of matter in the universe, a space that large should have something like 2,000 galaxies inside it. We found 60. The sheer, shocking emptiness of the Boat's Void is probably the most powerful evidence we have for this foam-like structure of the cosmos.
Okay, so we have this beautiful cosmic web model. It all makes sense. But what happens when we find things that are so enormous they seem to break the rules? Structures that actually challenge our fundamental understanding of how the universe is supposed to work.
And this is where the real mystery begins. Because according to our best cosmological theories, there should be a size limit, a hard cap on how large any single structure can be. And, well, we may have already found things that cross that line.
It all comes down to something called the cosmological principle. It's a core idea in cosmology, and it basically says that if you zoom out far enough, the universe should look pretty much the same everywhere. Smooth and uniform. This principle predicts that there shouldn't be any single connected structures larger than about 1.2 billion light years.
And then there's this, the Hercules Corona Borealis Great Wall. It's a vast superstructure of galaxies that's estimated to be a mind-shattering 10 times billion light-years across. That is nearly 10% of the diameter of the entire observable universe. According to our models, it just shouldn't exist. There simply hasn't been enough time since the Big Bang for gravity to assemble something that big. It breaks the rules.
And it's not just these gigantic structures that are breaking the mold. At the heart of some galaxies, we're finding objects that are also just impossibly large. In fact, astronomers have had to create a whole new category for them: ultra-massive black holes.
So, just for comparison, the black hole at the center of our galaxy is about 4 million times the mass of our sun. Now look at TON 618 at 66 billion solar masses, and the current champion, Phoenix A, clocks in at a staggering 100 billion solar masses. It is so enormous that scientists don't think it could have grown the normal way, by slowly eating stars and gas. One wild theory is that it's a primordial relic, formed directly from the raw energy of the Big Bang itself.
And that brings us right back to where we started. Remember that grain of sand? That's our home, our galaxy. Just one tiny particle floating in this vast cosmic honeycomb, surrounded by these incredible filaments, walls, and voids, and punctuated by objects so massive they literally defy our theories.
And this is the question that has to keep cosmologists up at night. We've basically reached the edge of what we can see, and we've found things that, by all rights, shouldn't be there. It forces us to wonder, what other cosmic monsters and grand designs are lurking just beyond the horizon, just waiting to rewrite everything we think we know about the universe?